All right, guys. Hey, everybody. Kevin Margo. I'm Creative Director of 3D at NVIDIA. With me are a bunch of developers from our internal Creative 3D team. We're a group of about 20 artists, technical artists, and newly formed pipeline team spread across the globe. Most of us are coming from a visual effects background and animation. We're a small production studio inside of NVIDIA. You can kind of think of us like a boutique studio you'd find in the commercial world. Their challenges, goals, and concerns echo ours. We make a lot of different content, cinematics, keynote videos, interactive demos, and everything in between. Like this DaVinci project that I'm about to show you. It started off as a technical exercise for artists training and a proving ground for pipeline developments. The goal is to challenge the craft of our artists and identify workflow requirements in a real-world use case. All right, I'm going to roll that. Can we dim the lights? All right. Okay, so thank you. Okay, so our team began assembling 4 years ago as our Omniverse platform was being first developed. The mission was to embrace forward-thinking workflows and be a first customer of emerging NVIDIA technologies. We had a lot of challenges. We started completely from scratch, building on top of rapidly changing technologies. We were working with incoming third-party data, and our outputs varied from real-time to offline and interactive. So we embraced USD and NVIDIA's Omniverse platform, building a pipeline to produce content like DaVinci responsibly and efficiently. I'll introduce you to our people trying to solve those challenges. Will Kavanaugh will start drilling down into the developments.
Cool. Thanks, Kevin. So our first step before building anything was to take stock of what already existed. When Will and I joined the team about a year ago, almost all of the organization and structure was managed manually. File system structure was created for each show from an empty template directory tree, which was manually copied. File handoffs were coordinated using Dropbox or by copy-pasting paths to files over a network drive or chat. And this, of course, led to all the problems you'd imagine. In particular, without centralized and well-defined rules about how data would be structured, development of tools is much more challenging. So we knew we wanted structure, but as Kevin said, we're supporting a team that moves between projects quickly and uses widely varied emerging technologies. So we also knew we needed to develop a system that could adapt and grow to support that. We already knew a lot about what we wanted to build. From our prior experience with USD, we felt confident it would make a great foundation. We wanted to reuse rather than reinvent as much as possible and lean on the tech available to us from the Omniverse ecosystem. And we wanted our pipeline to be able to scale and be reconfigured to meet the demands of each project. We didn't want it to be cumbersome to use. We wanted it to be easy to work in the right place and find what you're looking for. And we also set some limits on the scope of what we'd build. One of the themes you'll hear from us in the presentation is that you can see returns on investment in USD-based pipelines continuously as you develop them. We wanted to realize value quickly and not develop something for years before it saw production use. We knew that by just introducing some structure and leveraging USD composition intelligently, we could provide a lot of value for the team without building out all the complexities you'll see in many pipelines. We decided that for our team, for an initial product, things like versioning, dependency tracking, and offline workflows were less valuable than the complexity they introduced. So we kept these in mind. We kept the types of features in mind while we were designing, so we could add them down the road if we found we needed them, but we made the decision that they weren't immediate priorities for our team. Before making changes, we also wanted to know what to keep. We have a team of incredibly talented and experienced artists, and they'd already been delivering shows successfully with what they were working with. So we wanted to meet with them and hear postmortems on parts of the pipeline for Sing, which was their most recent show at the time, and took stock of what was working well. While it might seem obvious, I think this step provided a lot of value, not only because it gave a basis to build on, but also because users are always more receptive to a new system if aspects of it are familiar. So out of those discussions, we identified aspects of the existing structure that we liked. We liked that data was separated by production process and assets were organized into useful categories. Sequences and shots were stored hierarchically, and some of the artists had developed a practice of working with base files and delta layers to author superseding per shot opinions. We allowed artists a lot of flexibility in how they worked. We also identified what we wanted to change. The lack of defined and enforced structure, as well as a scattering of files across storage locations, meant that the source of truth for a particular piece of data was often ambiguous. File organization wasn't consistent from artist to artist, and spinning up a new show or generating a new asset required tedious manual work. All of the flexibility was perhaps too much flexibility, and we wanted to find a good middle ground. We also decided to adopt a fast iterative development process, deploying APIs and tools as early as possible, and testing with real data as much as we could. This meant de-risking, developing, and proving out concepts and APIs on a dedicated test show, as well as deploying early versions of our workflows and tools into real shows. We targeted high-return portions of the pipeline first, such as asset packaging, and rolled their APIs and tools into production separately from the rest of the pipeline. By designing our composition structure, file naming, and organization to be human-friendly without dedicated tooling, we've been able to develop and roll out pipeline components piecemeal and incrementally add value. So now on to the exciting part, what we're building. And to get into that, I'm going to hand off to Will Whaley, who's going to talk through some of the terms and concepts we've converged on and talk through some of the APIs we've developed. Then he'll pass back to me and I'll show you some of the USD structures that underlie our pipeline and a few of our pipeline tools in practice. Will?
Oh, all right. Thanks, Will. All right, so the first thing I'm going to do is read through some terms related to the pipeline structure, and I need to be clear on this as they're used throughout the rest of this presentation. So first, we have this thing called a context, which is a directory or node in a project structure which can be used to uniquely identify a path, or it can be uniquely identified by a path. We have a context type, which is a description that imparts specific meaning and purpose to a context. So a shot would be a really good example of a context type. We have a context name, so that's a meaningful name ascribed to an instance of a context type. So something like LTO10 would be a good shot name. We have something called an anchor, which is a high-order context used to organize and identify distinct production processes. It works for us similar to a scheme does in a URI. We have a workspace, which is a private place in a context owned by an individual or a process and used to execute a production step. We have an app space, which is a private place in a workspace used to organize the files used by a specific DCC application. We have a base file, which is the OpenUSD interface layer that composes a canonical scene description of a context, and a contribution, which is a public place, a public layer stack in a context used to organize the OpenUSD data in a meaningful way. So organizationally and in practice, a context can contain workspaces, base files, contributions, or other contexts. Workspaces can exist in any context. They're name aligned with production steps, so they'll look like model or rig or anim. An app space can exist in any workspace, and it's name aligned with a DCC application like Maya or Composer. We have the base files, and they can exist in any context, and we have contributions, which can exist in any context. So to restate, a context is just general organization. Workspaces and app spaces are for content creators, and then base files and contributions are the USD layers that serve as the foundation of our pipeline. So to implement the organizational concepts, we had to write a few Python packages and APIs, and I'll cover those next. But first, when we started, we had a few goals. We wanted these things to be self-contained, right? So we wanted to avoid bespoke databases and remote computer, third-party applications, et cetera, and the execution path. We wanted to be able to install USD Composer, connect to a Nucleo server, and just start using the pipeline. We also wanted to be cross-platform and cross-application. So to accomplish this, we chose to distribute the packages as Kit extensions. And we only wanted to use standard Python packages or those available through Omniverse connected DCC applications. We needed these things to be configurable. So policy, which is standards and conventions and settings, we wanted to configure as well as behavior through plugins. Then we wanted to be considerate using semantic versioning and test suites. So the first package I'll go over is a context manager, which is used to define an interface with our context. It contains a sparse workspace, app space, and contribution implementation. It's backed by UI and USD Composer and a Python API. It's configured using TOML, as you can see on the right. So inside of it, context type, metadata, and policy can be defined. So our context structure is defined. This is how we define our shot structure. Plugins can be configured. So the second package that we developed is the asset structure package, which is used to define and interact with OpenUSD asset structure. It's backed by UI and USD Composer and Python API as well, and it's also configured using TOML. It supports per category asset structure, so like a prop. We have a shorthand for specifying composition arcs when we build out our asset structure. Contributions can be defined, metadata can be added, it supports dependencies for derivative stages, and it supports plugins for scene data processing. So now we've talked about the structures and the APIs. We'll take a look at how they manifest on disk in an idealized and simplified shot. So first, we have this context. It's just a formalized directory. And inside of that, we have a base file. And we have some contributions that facilitate collaboration. And we have a workspace for an animator and an app space for their Maya files. So I'm going to hand it back to Will, and he's going to talk a little bit more about the USD structures that we use.
Thanks, Will. Cool. So let's dive into the asset package's USD structure in a little more detail. As Will mentioned, our context use base files as the interface layer where the context scene description comes together. For asset packages, the base file's file name is just the asset name. The base file brings in contributions. The four contributions that we define for asset packages are geometry, material, proxy, and preview. And contributions that have multiple options to select from leverage variant sets to author those options. So for instance, the material contribution authors multiple resolutions of renderable materials, an off variant to disable material contributions, as well as an anim variant that allows us to load USD preview surface shaders only, which is what we use in the animation production step. We bring the contributions that author variant sets into the base using the reference composition art, since this allows us to make variant selections in the consumed asset with payloads disabled, meaning we can interface with a very lightweight asset package, sans payloads, and only load the contribution contents when we need them. As with assets, our sequence and shot structure relies heavily on USD composition. Sequences act as a basis for shots, meaning that we're able to author a starting point for all shots in the sequence once, and only author deviations from that basis in each shot itself. Like with assets, sequences and shots have a base file that composes contributions. Here, those contributions are things like assembly, finishing, anim, and camera. We reference the base of each asset's package that we're interested in consuming in the assembly contribution. author transformations, lighting, et cetera, and finishing, and so on for the other contributions. We have a special override contribution that authors the last say and is composed as the strongest opinion in both the sequence and shot base. This is a rarely used but powerful mechanism to make a change that affects every shot in a sequence and can't be stepped on by opinions authored in the shot. So now you've seen the underlying APIs and structure, let's take a look at it in action from a user's perspective. Using the context manager front end, users can easily create a new project and in one click stamp out the templated hierarchy and USD structure, all using the context manager API under the hood. Another tool called Asset Builder sits on top of the Asset Structure API and takes care of extracting asset contributions like rig, material, geometry, and generating a packaged asset. It uses a configuration to automatically generate scaled textures and sets up the authoring of material variants, geometry variants, proxy geometry, etc. Back in the context manager, we can stamp out a sequence and shots in our show using brace expansion to automatically name a set of numbered shots based on a convention specified by the user. This, of course, offers a huge time savings and error reduction over the manual processes it replaced. By double-clicking the sequence in the context manager, we can open its base file and composer and set our authoring layer, the edit target, to the assembly contribution sublayer, reference the asset we just published, bringing it into the sequence. This will mean that the asset will now appear in all shots for the sequence. We can jump into one of those shots base files and see that the asset comes in through the sequence contribution. Next, let's set our authoring layer to the finished contribution sublayer and add a transformation to our referenced asset at the shot level. And to show that the transformation was authored to the contribution, we can mute the sublayer and see that the transformation we authored is disabled. So now that you've seen the tools we use to generate the structure and publish assets, I want to hand it over to Gage Hedden, who's a technical artist on our team and is going to talk through some of the artist-facing tools he's developed leveraging the same APIs and structure, but with a lot more polish. Gage?
Thank you, Will. Good afternoon, everyone. Let's quickly go over the agenda for today's presentation. I'll provide an intro of my role as a technical artist, showcase some of the tools that have been developed, explore tool ideas, then lastly conclude with a video bringing the concepts to life. So when I joined NVIDIA, my focus revolved around artist-oriented tasks, as seen in the image on the left. This image was a personal project, which I introduced to Omniverse as a way to acquaint myself with the platform. However, it didn't take long before I ventured into the realm of tool development and beginning my journey as a technical artist. Now let's explore some of those tools that were developed as a technical artist. We'll start with Shot Manager. So Shot Manager is a tool I developed during my early days at NVIDIA. Its primary function is to store vital information to a database. It encompasses quality settings, rendering options, resolution, output path, and more. This tool plays a crucial role when artists need to render jobs, either locally or remotely. Over time, Shot Manager received significant enhancements thanks to the invaluable contributions of the Wills, in which the APIs have insisted in features like importing shots directly from projects to automating camera fields and ranges. Now let's take a closer look at how this tool transforms the rendering process and enhances productivity. So Shot Manager streamlines the rendering workflow, provides additional context menu options, some of those which lead to faster navigation, with its ability to load and locate USD files, quick inspection by opening output directory to review rendered frames, and lastly, seamless collaboration with its capacity to switch between artists easily. Here we see some of the capabilities of Shot Manager. For instance, we can manage projects by adding or removing databases locally or on NFS to facilitate collaboration, control farm instances through the addition or removal of queues using IP or DNS, customize shot statuses from first to final passes with the option to customize as needed, and flexible theme settings for a customizable workspace. Shot Manager also streamlines communication with Slack integration, providing optional notifications upon submission. Here we have a glance of what the workflow might look like from start to end. Once shots are ready, right-click from the context menu, render individually or in batches. Lastly, we can monitor those jobs using tools like Farm Status or the Omniverse Farm Dashboard. In a recent addition to Shot Manager, it leverages texture streaming, allowing us to set the maximum resolution for texture maps. In addition, we also have the option to disable materials. This feature proves useful for tasks such as evaluating untextured models, debugging, or generating behind-the-scenes content. Here we have a look at Shot Manager's REST API, enabling integration and automation directly through code. For instance, when developing tools to build certain USD files, we can leverage the API to send content directly to the farm for rendering, streamlining the entire process. This image shows the early stages with only minimal USD integration at the time. Now I'd like to talk about the turntable tool. This is the turntable tool, which was developed to solve a common problem you might be familiar with. For example, a 360-degree reference for objects and characters, animation reference for character movements, assessment of lighting and shading from different angles, and oftentimes used in portfolios and presentations much like this one. Here we have a glance at the API with a simple endpoint. In the snippet on the right, a basic path to the USD file begins the process. Because of the backend setup, in just a few minutes after posting that request, our team will receive a turntable video directly in our dedicated Slack channel. And here's some of the sample images of the turntable tool. On the left, we have the astronaut scene with a couple HDRs and an untextured model. On the right, some props from the Da Vinci scene. Our asset structure not only allows the turntable tool to process individual assets, but we can scale up and process the full project if needed. Additionally, when using the USD API, calculating bounding boxes for framing becomes simple, yielding ideal turntables in most situations. Now I'd like to discuss the conceptual ideas we had. This is Resource Manager, another conceptual idea which was designed to be an asset storage tool, allowing us to bring in various assets in the scene. In this example, we showcase assets from Da Vinci. While once considered a daunting development task, the structural groundwork and contributions by the Will have transformed this concept into a reality that can now be achieved in a fraction of the time. This is Project Manager, another conceptual tool that provides a view of all assets for that project, illustrated here with another example using Da Vinci. Some features include transitioning between projects, publishing assets, an interactive view to explore lights, untextured and textured models, along with essential metrics such as triangle count and VRAM usage, which could help a lot when troubleshooting. Various methods of filtering, for instance, if we only want to see assets that are pending approval to evaluate the work that needs to be done. Project Manager showcases the potential of utilizing the structure our team established. This tool and Resource Manager on the previous slide are just for illustrative purposes only and are not currently available as functional tools. As we draw this presentation to a close, all right, this is all the time we got, so that's all I got for you folks.